In this video, we're gonna be talking about another Leetcode question, and it has been tagged for the Amazon, like the question being asked by Amazon. It's a very hard question. Basically, they have provided you two um, sorted arrays, nums1 and nums2, and they want you to come up with the median without actually with the runtime complexity of O log of m plus n. So the brute force, if we don't have to come up with this one, right? Uh, the brute force is gonna be, which is gonna be the linear runtime complexity, is to put them uh, in one array and then just calculate the median by, if it is odd number of elements, we're gonna become when we're just gonna be returning the middle element. If it is even number of elements, even number of total number of elements between nums1 and nums2, we're gonna be taking the average of the two middle numbers. But this becomes a hard problem when we have to actually, and in this case, as they did mention that they are sorted and we are not making use of that. Well, we are still making use of it because if they have not been sorted and we are trying to put them in one array, even with the brute force, um, yeah, like it would have been not that simple, because then we have to sort them first. Just talking about the brute force here, sort them first and then try to put them in one array. So we are still making use of the sortedness, but still the complexity is uh, a little bit. We want better solution. So yeah, so we need to come up with a logarithmic solution, right? So what we're going to be doing, instead of taking for the pseudocode, instead of taking this example of 1, 3, and 2, because the 2 is going to fall in the middle here, and that's what we wanted to return, which is going to be the answer. What I would suggest is, let's start with A equals to 1, 2, 3, and B equals to 4, 5, 6, right? So the algorithm is gonna be that our I and J, they are gonna be starting from the starting point of array A and array B, and then we're gonna be basically calculating the middle points. When we do calculate the mid points of them, either, let's say the middle comes out to be here at the beginning, so we can say, depending on the depending on the value of the A mid or and B mid, we can actually decide, do we need to actually go for the next iteration, do we need to look into the right side, or or the left side. So basically, do we need to look between the right of I and left of J, or we need to actually look between left of I and right of J. So okay, again, as I mentioned, that every single time we wanna check that the answer may lie between A right plus B left, or B right plus A left. Again, let's just go through the logic here. So we're gonna start with, so this is basically the algorithm here. that we are saying that, let's just say that the total number of elements in A is 3 and the total number of elements in B is 3. The L and R are gonna be, we need to actually do two things in here. Our left and our R is gonna be uh, the wave, the total number of elements we want to start, because this L and R, they're gonna be divided by 2, they're gonna be logarithmically get into half every single time. We need 2 because we know that there can be even and odd number of elements. So in order to calculate the L and R, the only difference is that we want to have the total number of elements plus 1 divided by 2 and plus 2 divided by 2. So that if you look at the array here, right, we want to have our element L over here and R over here, so that everything we actually try to come up with the even and the odd number of elements. So the only difference between the L and the R is that one time we are actually dividing the total number of elements plus 1 divided by 2 and total number of elements plus 2 divided by 2. Okay, and then once we have our L and R, the result is equal to, we're going to be sending it to a function, right? And then it's going to be the first array and the starting point of that, then the second array and the starting point of that, and then L, and the same function with R over here, and we're gonna be taking the average of that. That's gonna be the result. In that function, right, this is the get kth function, right? We, depending on the value of the k, we are actually gonna be looking into a couple of things in here. So as we said, the result is gonna be equal to the function of this and the function of this. Like one time again, all we are sending in this function is the array A, the starting point of A, the array B, the starting point of B, and the k, like how much iteration we have done, and because k is gonna be the kth element in here. Okay, so as we're gonna be separately calculating this function and this function for the left side and for the right side, and again the left and the right, the only difference is because of even and odd, we need to have two iterations in here. Okay, now calculating this one, right? So for this function, the first thing we do in this function is that the start index, which is 0, and the start index of B, which is also 0, does it do they are inbound, not crossing the size of A. So as we know, the size of A is 3, the size of B is 3, so they are inbound, and we are not having the overflow in here, so we are good in there. So these two lines are gonna be basically checking that, okay, are they in do they lie within the limits of A, the range, the length of A and B? So yes, they do. And the last thing is that we definitely want to make a decision when the k is the first element. So when the k becomes equals to 1, we can actually decide on what we want to return based on which element is smaller. The A minimum is smaller or the B minimum is smaller. Okay, then we're gonna be calculating we're gonna start our mid with the max. A mid and the B mid is gonna be starting with the max, right? And again, all we need to check is that the starting plus the kth element, which is gonna be k divided by 2 minus 1, if that is still within the A dot length, which is 3 in our case, we're gonna say that we need to update the A mid and the B mid. So the A mid is gonna get updated to A start plus, again whatever we did over here, A start plus K by 2 minus 1. We're gonna be actually saying that the A start was 0, K is we started with K equals to 3. So the K is 3. 3 divided by 2 is 1, minus 1 is 0. So A start. So our midpoint, A mid, is gonna be A of 0, which is equal to 1. A of 0 is 1. Okay, we also know that the B start plus K by 2 minus 1 is less than B length. B start was 0, K is 3, 3 by 2 is 1 minus 1 is again 0. So B start, which is 0, is less than the B length. That is correct. So we want to update our B mid to B start plus K by 2 minus 1, which is going to be B of 0th element, which is 4. So we're going to come up with 4. Again, after that, we just need to check if A mid is less than the B mid. So in this case, the A mid is less than B mid. That is true. So all we need to do is to return, we all have to do is to return this function. So the function is that A is gonna be sent and B is gonna be sent every single time. There are three elements which change: the starting point of A, the starting point of B, and the kth element. So we are gonna increment the, not increment, it's basically the A start plus K by 2, right? So that is gonna be incremented, or it's gonna become equal to 1, and B start is gonna stay the same, and the kth element is basically getting divided every single time by 2, k minus k minus k by 2. That's the logarithmic division every single time happening. So this is gonna be 2. Okay, so now we basically, this and this, they have the same answer. So now we're gonna be working on this one. So A1, again, the first thing we're gonna be checking is, do these starting points 1 and 0, do they lie between within the bounds? So yes, they do, as this has goes up to 2 elements, and so starting from the 0th index, it goes to 0 1 2, and again same way over here 0 1 2. So both of them are within bound, and k is this one. So and k is not equal to 1, so we won't be making any decision in here. Again, we're gonna be updating starting with the max. We're gonna initiate the A mid and the B mid with maxes numbers, and then we're gonna be saying that the start A start plus K by 2 minus 1, is it less than the A length, meaning are we inbound with the kth element, with respect to the kth element, are we inbound? So yes, we are, because k is 2, 2 by 2 is, so basically this turns out to be 0, and A start is still within bound of A's length, like within the elements of A. So that is correct. So in the end, we're gonna be updating our A mid to the A start of like A start with respect to the kth element. So that is gonna turn out to be 2, and then the B start plus K by 2 minus 1, which is gonna turn out to be 4. Again, B start was 0. B start was 0. This is K is 4. So K is 2. 2 by 2 minus this becomes 0. So everything becomes 0, and it is going to be B of 0, which is equal to 4. At this point, we see that we're going to again compare 2 with 4, and we are still A mid is less than B mid. So we're going to just increment over here, the nothing is increment, nothing is changed other than the starting point of a, and k is always gonna be k is equal to uh, k minus k by 2. This is the one. And in over here, this time they do still are within the bound, but k has become equal to 1. So when k has become equal to 1, we can make a decision. And if you look at the logic and keep doing this algorithm, the pseudocode, you will notice that when the k is equal to 1, this is actually not really changing. This k is 1 minus 1 by 2 is 0, so that always remains the same. So we are not actually changing the k anymore. So we can make a decision over here that we're going to be we're going to be returning the minimum between the a start and b start. So a start was 2, b start was 0. So basically we are here that we are comparing this 3 with 4, and whatever is the minimum, we are returning that. So this whole thing, the result was we're gonna be getting to the result with these two things. So this thing is gonna be returning 3. Now we have to calculate this one, which is the other leg, where the k is equal to the right, which was like that. So again, with the similar logic, we started with the initial starting points of a and b, right? The only difference is that the k is equal to 4 this time. So they are within the bound and k is not equal to 1, so we won't be making any decision. All we have to do is to calculate the a mid and b mid starting with the max, and then we're going to be updating them. The way we're going to be updating is like, do we the starting point with respect to the kth element and the starting point of b with respect to the kth element, do they lie within the range of the first array and the second array? Yes, they do. As you can say that 0, like the 4 divided by 2 minus 1 is gonna be equal to 1. So is this thing becomes 1 and this thing becomes 1. Do they lie? Yes, they do. So we want to compare, we're going to make a mid and b mid. We want to calculate that. So that is going to be 2 and 5 as a of 1 and b of 1. 2 and 5, 2 is less than, so we want to compare the a mid with the b mid. So a is less than that, so it's gonna all gonna what's gonna update is the starting point of a's array and the kth element. Okay, in order to calculate that, still they're gonna lie within the range, right? And then k is not equal to 1, so we won't be making the decision. We're gonna start with the a mid equals to max and b mid equals to max, and then we are gonna be seeing that do they lie within the range with respect to the k. Yes, they do. And then we're gonna be updating the a mid over here to 1 and 4. So what it turns out to be is that the a start plus this is actually becoming uh, uh, 0, and the b start. So what was the a start here? A start was 2, and k is again 2. 2 divided by, so it is actually yes. So the a start is 2, right? So a start is 2 plus this is equal to 2. 2 is 1 minus 1 is 0. This becomes equals to 0. And the a star, which is equal to 2, right? A start is 2. So we are actually looking at a2, 0, 1, and then 2. There is gonna be 3. Okay. And the next one is b star, which is again b star was 0, and k by 2 minus 1, that is again this is 2 minus this is 1 minus 0, that becomes 0, so it stays 0, and that is fourth, so that is gonna 4. B of 0 is 4. So again, still with that this thing is true, that the a mid is still less than the b mid, so we're gonna be returning, all we have to do is to update our a, which is over, a is gonna be 3, like the starting of the a's array is gonna be 3, b is gonna stay the same, and this time what's gonna happen is like this condition where we are actually looking, because this is out of bound now, we do not have a of like the a3 element, a can go from 0 to 2, so this is out of bound, so all we have to return is b start plus k minus 1, which is gonna be the starting position is 0 and k is this is gonna be 0, so basically it's gonna be b of 0, which is equal to 4. So once we are returning 4, once we were returning 3, so we're gonna take the average and return the result. uh, this is kind of hard, and it is but once you actually follow through this one, it starts making a little bit sense. So yeah, that's all I wanted to cover. We already talked about the time complexity. It is logarithmic, and in terms of space complexity, um, we are not really uh, doing saving anything in here, right? But if you actually do consider the space of the stack, because every single time we are actually gonna be doing it, so that if you consider the space of the stack, it is also logarithmic, that recursively we are actually going back again and again, so that may take logarithmic space too. That's all I wanted to cover. Thanks for watching.